I thought I'm gonna go over a few multiple choice questions from atomic and nuclear physics. And so here's one question that I found online. So one way to model the allowed states of a hydrogen atom is to treat the atom's single electron as a standing wave with a wavelength lambda. Which of the following could be a radius of the orbit of the electron in such a model? Select two answers. So what they're saying in this question is that you can represent an electron as a wavelength, and you can have one full wavelength. So let's say I'm going to go from the trough to trough, so that would be one full wavelength. Or you can have from trough to trough and another from trough to trough. So you would have two wavelengths. So you would have from here to here one wavelength, and then you have the second wavelength. You have 3, 4. So I can do the same for the spin of the electron inside of the atom. So I can say this is one wavelength, this is another wavelength, and this one is the third wavelength. So in this case, I'm going to have n equals to 3 wavelengths. For the next one, I would have n is equal to 4 wavelengths, and then I would have n is equal to 5 wavelengths, and n is equal to 6 wavelengths. And from de Broglie's wavelength formula, we know that the wavelength is equal to the Planck's constant divided by the momentum, or you can say the Planck's constant over the mass times velocity of the electron. I broke this chart into like a little bit more visual. So what I'm gonna say is when n is equal to 3, that means the 3 wavelengths. So right here I have 3 wavelengths fit in a circle, and the circumference of the circle is 2 pi r. So that means if n is equal to 1, you would have lambda is equal to 2 pi r. And and let's call it different radius, so r1. And then if you have n is equal to 2, you have 2 lambda is equal to 2 pi r. And so for n is equal to 4, you have 4 wavelengths fit in the circle. So you have 4 lambda is equal to 2 pi r. And it can be a different radius. So radius, let's call it radius 3, radius 4, and so on. So for n is equal to 1, you will have lambda, 1 lambda is equal to 2 pi r, and the radius is going to be different, our radius 1. So if I start solving for each individual one, so in n is equal to 5, I would have 5n is equal to 2 pi r, and then the 5th radius, and then 6 lambda, so lambda is equal to 2 pi r, and the different, like 6 radius, different radiuses for each, or radii for each. So if I solve each one of them for the radius, then I have 3 lambda over 2 pi in this case. In this case, I have 4 lambda over 2 pi. In this case, I have 5 lambda over 2 pi, and in this case I have 6 lambda over 2 pi. So I also can say for every individual case, for n number of wavelengths in a circle, the radius is going to be n times lambda over 2 pi. So if I look at the possible answers, I see that every single one of them needs to have a pi in the denominator, and one of the radii that they give me, d, does not have a pi in the denominator, so that would not be one of my choices. So if n is equal to 1, then the radius is going to be equal to lambda over 2 pi. And I see C has that answer, so that's one of my choices. If n is equal to 2, then the radius is going to be equal to 2 lambda over 2 pi, or lambda over pi, that's something that I see there. If n is equal to 3, then r is equal to 3 lambda over 2 pi. I don't see that answer. If I continue this way, looks like for n is equal to 8, actually to 4. If n is equal to 4, then r is equal to 4 lambda over 2 pi. And that will give me 2 lambda over pi. So the next answer that I could have is the A. So the correct choices would be A and C. In this question, they say 3 reactions shown above with unidentified particle X and Y occur in manufacturing process of plutonium. What particles do X and Y represent? And you have to remember again that the number of the protons and nucleons on both sides of the equation must be the same. So that means this particle has a 0 for the proton, and this particle has 1 for nucleons. So since nucleons are protons and neutrons, and the particle has 0 for protons, X has to be a neutron. So in multiple choice answers, these two have neutron for the choices. And then for the second part, and I looked at this right here, you see the sum of them has to be equal to 239. And then for the second equation, again, I'm going to look at the right side protons and at the left side protons. So looks like Y, so antineutrino, has 0 for protons and neutrons or nucleons, and then Y must be a -1. And for nucleons, this one has to be a 0. And a -1 for the particle would be a negative beta decay. So I see the only choice for Y for negative beta decay is going to be D. And then let's see just one more time to check the next equation. I have 93 and I have 94. So again, I need a -1. And I have 39 and 39 on the other side. So that must be 0. So in both cases, Y is beta negative particle, which makes the correct answer D. In this next question, they say that plutonium nucleus with mass M is at rest when it spontaneously emits a high energy photon of frequency F. After the decay, the photon moves off in one direction and the nucleus recoils with speed v in the opposite direction. The nucleus's mass decreases by an amount of delta m, the mass defect. Which of the following equations correctly represents the conservation of energy in the decay? So the energy before anything happens is 0 for conservation of energy. We have energy before is 0. And after, if the energy is conserved, is going to be the energy of all the elements. So one is the plutonium that lost the mass defect. So we have 1/2. The energy of the plutonium is 1/2. Its mass minus the mass of the lost during the process times its velocity. So that's what's left of plutonium squared. Then after, I also have the photon of energy h, frequency of the photon, and I also have the mass defect or the loss of the mass, and that loss of the mass is negative delta m and c squared. For the mass itself, it's going to be the energy converting into the energy, the mass defect, it would be mc squared. And because this is the amount of the mass that has been lost, multiplying by c squared gives me the amount of energy, not just the mass, lost. So the correct answer in this equation would be A. If you move the mass energy lost, the defect of the mass that has been lost, you see that we can rewrite this formula into that formula. And thank you for watching this video. If you find more multiple choice questions or FRQ questions that you would like me to solve and record and explain, just send them to me. And thanks, and I'll see you in the next video.